Hello, welcome to my presentation about clean coding principle in C#. In this video, we'll talk about clean coding principle. So first of all, we'll see why do we need clean code. Then we're gonna see how to create clean names, how to create clean methods and functions, how to write comments, have clean comments, how to do the formatting of the code, how to do the error handling, unit testing, classes, conditionals, and lastly, we're gonna see how we're gonna proceed so that our code base stays clean. Good. Next, we're gonna see what the motivation is about having clean code. So first of all, if you are a programmer with clean coding, you will be, of course, a better programmer and a more professional programmer. Of course, there will be code in the future, so ChatGPT and these kind of tools will not replace our work. They will just ease the writing of code, but we still have to think with our heads. And yeah, we will never get rid of code. Before talking about clean code, let's see what bad code is. So why would someone write bad code? There are different motivations. So first of all, do we want to finish something fast, or do we want to finalize a module to please your boss, for example? Or is your code base very bad, so you have only bad code and you want to stay in the same bad style? Or what other motivations? So for example, if you want to finish something and throw in some ugly code so that it just works, but it will be a maintenance nightmare. Let's see, for example, we have here a diagram. We see the slowdown, which is caused by bad code. So at the beginning, we see here we have the productivity. When we start, the productivity is very high, so we have 100%. So we implement code and do some features. And in time, if the code base, if we start writing bad code, the productivity is decreasing down to 0. What would be the solution if we have only bad code in our system? One solution would be, should we redesign the whole system? Yeah, the problems here are that the old system has still to be maintained also, and it can take a long time based on the project size. And when it's done, so the refactoring is done, the team members are already gone also, and the new ones will probably request another redesign. Of course, in this case, the solution would be to keep the existing code base clean. So that's the only option, and we have to ensure that the existing code base is kept clean. We have to adopt a professional attitude, and it's our job as a professional software developers to defend the code, to keep the code clean. Here we see some axes. So what exactly wants the boss from us? He wants that we write fast, we implement the features fast, but it doesn't care how the code is looking, so it's dirty. As a programmer, we should strive to be in this other part where we write fast code and also keep it clean. And there are two theories here which I want to emphasize. So for example, we have this broken window theory and the Boy Scout rule, which applies to clean code. What does this two say? So for example, the broken window theory says that this house is like our code base. So if there is bad code in one part, so for example, we have a broken window, so this will lead to other broken windows, because if someone implements a change, he sees that the code base is ugly, and then he is tempted to keep the same coding style, and we have other broken windows, other bugs, and so on. And one solution would be to have this Boy Scout rule. So this means basically to if we do some changes, so to leave the campground cleaner than you found it. It's the same like in camping. So if you do a change in a particular code, then you have to leave it cleaner as you found it. So if you found some problems there, some bad code, you have to try to leave it cleaner as it was before. Good. Why would we need clean code? I want to make these points again. So basically, reading the code is harder than writing. So you have to take care that each line you write is read afterwards 10 times more. So it's good to write clean code from the beginning so that you don't have issues reading it and making it harder for other developers to understand your code. And also it's faster, so it's faster to write clean code because you follow the same clean rules, which makes it easier to develop software, and also it's easier once you master this clean coding design. Principles of clean coding. So we need to have the right tool for the right job. We need to have this high signal to noise ratio. This means, like in this radio communications, to have the least lines of code in order to express a different functionality. This means you shouldn't have unnecessary comments, unnecessary white spaces, and things which clutter your code base. And your code should be self-documenting to not have unnecessary comments, for example, and the methods and class name should be very well written. Here is an example for the right tool for the right job. So for example, you want to maybe to validate something with a regular expression, so you can use this one. Would you use such a regular expression for validating your email address? I think this is a regex for email validation, but this is not recommended because if you have to change here something, it would be a nightmare to do it. Also, you have to watch for boundaries in your code base. So for example, to not mix different technologies, to not have dynamic JavaScript in C# code and HTML in JavaScript files, or vice versa. Avoiding inline CSS in HTML. So ideally, CSS files should be kept in their own files, and also avoid HTML in SQL databases. Good. Here is a problem we face. So for example, we can have these JavaScript files which we kind of inject in the front end from C# code. This looks really ugly, but it's problematic because maintaining this is very hard because we don't have IntelliSense. It's just a simple string. The solution would be to put this directly into the front end. It looks much better, and we have this code coloring, and yeah, it's easier, autocomplete and stuff like that. Okay, we should have one language per file. So the motivation of this is because this enables caching. So for example, CSS files and JavaScript files can be cached for faster retrieval once they are loaded once. This code coloring is very helpful. The syntax is checked. We have the separation of concerns, so things which are related are in the same files. Reusable code is done in different files, and we avoid this string parsing, which causes errors sometimes. And of course, the CSS files, JavaScript files can be minified by different technologies and faster load times. We talked about this maximizing the signal to noise ratio. We see some things which are okay, so which creates good signal. So the code should be expressive, does one thing, so methods and classes are very related, well structured, and then the noise, something which makes the code uglier, are things like huge classes and methods, repetition, no white spaces where they are needed for readability, or zombie code, so code which doesn't belong in that place. For example, commented out code or code which is not called at all. Good. Let's see an example of how to refactor a method to make it more clean. So we have this method here which has some nice summary. We have some also comments, but in the end, it's not really clear. So it takes some time until you understand this. It's much more cleaner to have something like this, to have a self-explanatory method name, and then we have some conditions, and the comments shouldn't be put here because we have the history of the files, and if we need to see why something has changed, then we can check the history of that file. We have this don't repeat yourself principle. This tells us it's like the same like in database normalization. We have the first normal form, second and third one, to not repeat the same records in different places. And in the code, basically the copy and paste, if you do copy and paste, this is basically a design problem. The duplication decreases this signal to noise ratio, and also increases the lines of code. So increasing lines of code makes the code harder to read, and it creates a maintenance problem. We should strive for self-documenting code because the understanding of the programmer's intent is the most difficult problem. The well-written code is self-documented with nicely written variable names, classes, and we should have these layers of abstraction, business logic, UI, and so on. And format the code so that the readability is increased, to have the spaces where needed, not too much spaces, of course, and to have code which doesn't have us to write also comments to explain it. Talking about naming, let's see a method name which is not so good example. So we have here decimal G, which we have a list of P's and we return a T. That's not really a good example. We should strive for giving it a good name. So if I get total, we have a good name here, and we have a list of prices, and in the end we return the total price. So this is clear without thinking too much what this method does. Good. Talking about class naming, classes should be the name should be a noun. It should have a single responsibility, be very specific, and avoid some generic suffixes like info or something else. Let's see some bad examples. So user info, so this is info is a suffix which is not really needed, it just adds some noise. Website business logic, my function, common, manager, utility, these are magnets for attracting too much code where it doesn't belong. So we should name our classes and make responsibilities clear. So here on the right we have this user class which represents a domain in the real world, so basically a user. The query builder, user repository, and these are account. They are very clear names which are doing that things which a class should do. So they should be a single responsibility and be very related functionality in these classes. Let's see something about bad naming. So bad naming are some methods which is not very clear when we read it. So we don't understand what they are doing. So we have this go, get, start, process, do it is not available. This negative naming is very, makes the code harder to understand. Let's see some better names. So we have some specific names: get registered user, send email, import document, is valid card. So these are names which tells us nicely what the respective method is doing. We should avoid also side effects of methods. So for example, a check password method should only check password if it's okay or not, and shouldn't do other things like log users in or out. Get user shouldn't update last access time, or charge credit card shouldn't send emails. Validate order shouldn't save orders. So these are some examples. We have here some naming warning signs. So if you see something like and, if, or in the method naming, then it's an indication that this method does more than one thing. So we should avoid such methods. And I would recommend to, for example, here we have this save user and send email. We should create two methods, one for save user and the other one for send emails, and call them in the respective orders if we have to. We should also avoid abbreviations because it's not a problem with storage space and with the RAM usage. And we should talk about code in a domain-specific language which can be understood by each stakeholder. Here are some bad examples of naming classes: reg user, resist user, regis user. We should basically tell the whole name. So this is much more clear and understandable by anyone. Good. Let's see some Boolean names. Some bad naming is open, start, status, logging is not. Again, this negative formulation. So we should strive for better names like is open, done, active, logged in. You see the condition checking is much more natural. And also we should be symmetrical. So some bad names are, we have variables which means the opposite. We have on, disable, lock, open. We should basically have them like symmetrical naming: on, off, lock, unlock, min or max, to be very symmetrical. Good. Methods and functions. So basically methods and functions are very similar. The difference is that methods are associated with an object, whereas functions can exist on their own. But in this course, we will use these terms interchangeably. Some indication on how to create a function or when to create a function. Basically, if you want to avoid duplication, if you want to make a better indentation of our code, to eliminate unclear intent, and if the method we are writing is doing more than one thing, we should separate this into more methods. Less is more applies also to software development. We have this don't repeat yourself principle. To if we have code which is repeated in different places, we should extract this to a common method. Code is a liability, and basically less is more also in our code. We see an example right next. So we should look for patterns. So if we have code which is duplicated and looks very similar, we should maybe extract this if into a method and call this method 3 times with parameters. So the parameters are things which are variable among these 3 if statements. Okay, we're gonna talk also a bit about this arrow code. So what is arrow code? So it's code like which looks like this. So we have this form here, a lot of ifs, netted ifs, and it's very hard to read. So if we have in our code somewhere more than 2 or 3 ifs or 4 nested loops, then it makes our code base very hard to read. So one solution would be to extract a method, some of these ifs to extract a method, to return earlier if some checking is not okay, or to fail fast. We have different approaches. We will see how to go on with this. The extract method works like this. So we have here some nested ifs and a while. What we can do to increase the readability is to extract this complicated logic. From here we create a method, and this makes the code a bit easier to understand until this point. Another thing we can do is to fail fast. So we have here some checking, if else. It's a bit easier if we check here the arguments right at the beginning and throw exception. So the nesting is a bit eliminated here. And we can also enable our code to return earlier. So we have here again this error code, and what we can do is to return earlier in case some of these checks is not okay. So it's perfectly okay to do this if the code is simple, if the methods are short, and then this indentation is not so big. and this looks more linear and makes it easier to understand. Okay, another thing is we should create a method which conveys intent. So for example, if you have here an if, it checks for zip file, something like that. Is not so clear for anyone who reads this. So to make it more clearer, we can create here a isValid zip file method, which is very clear for everyone what this does. And methods should also do only one thing. It helps the reader to understand the code. It promotes the reuse of the code and makes the naming and testing easier. Doing one thing also avoids side effects. And yeah, another thing which I recommend is to avoid Boolean arguments passing to functions, because if you pass a Boolean, this means that this function does more than one thing, one for if the Boolean is true and another thing if the Boolean is false. An example here why we should avoid flag arguments. So we have this create user method which creates a user and also send an emails. It has two responsibilities. We should ideally separate this into two different methods. Output parameters, I not really recommend output parameters. The intent of the function is not really clear. We have this parameter, the name should tell the functionality without looking at the implementation. And with object-oriented programming, output parameter should be avoided. So if a function must change the state of something, it has to change the state of the owning object. How many parameters should a function have? So ideally, mostly one parameter should be okay, something like that. We have this register user, which takes a user. We have also dyadic function, which a dyadic function has basically two parameters. They are harder to understand than a monadic function because yeah, if you have the second parameter, this makes you pause on the second parameter to ignore the first parameter, and this can cause problems because ignoring a part of the code can make it harder to understand the method. One perfectly valid dyadic function is something like this, where you have a point where you have the x and y axis. This is a perfectly valid example of a dyadic function. Triads are basically functions with 3 or I don't know more parameters. They are significantly harder to understand than dyads with 2 parameters. A solution would be to create argument objects. So for example, looking at this method which takes first name, last name, state, phone, we should strive to create an argument object, a user which gets all this data and which makes it clearer what this create user method expects. We have different signs that a method is too long. So for example, if you have too many white spaces and comments, scrolling is required to see the whole method. The naming is not clear, you have multiple conditionals, and it's hard to understand. A method should really be over 20 lines and should really have over 3 parameters. We have also this concept of command query separation. So functions should either do something or return a value. Doing both leads to confusion because the code is then not so easy to understand. So for example, these are not so good example because you have the publish report. What does this do? It's not very clear if it returned a report or publish the report. Adding an item to a list is also not so clear because it returns something and you don't know why it returns this number. Yeah, this is a violation of the command query separation. Good. Let's see an example. We have here a try catch block, which basically does here some in the try, do some complicated logic, supposing it does this thing. A better solution would be to put this complicated logic into its own method, so it's then clear what is happening inside the try catch, and then it's also easier to see why we get an exception or not. Good. Now we're going to talk a bit about code comments. How would you write code that's readable and maintainable with comments? That's the question. Well, the response is it depends. So you rarely need to add comments to the code. The comments, are they great or a code smell? We should prefer expressive code over comments, and using comments only where code isn't sufficient. So comments to avoid are redundant comments, intent comments, apology warning comments, zombie code, bloated header, defect log, and we'll see each one of these. So redundant comments are something like this. You simply express something which can be read also from code. Also these header comments which simply doesn't say anything additional to this method, so the method name should be clear. I would not recommend such comments. Intent comments, so for example, here we have a comment which tells what this check is doing, so instead of this we should create here for this to status status active enum, and this is more expressive than the first check. We should avoid apology or warning comments, something like this. We shouldn't apologize with comments, and we should fix the code before committing or merging something. If we really have to, we can create a to-do marker comment if we have, and something like that. We add a to-do, and this to-do is visible in Visual Studio also. In this, we have this task list window where we can see each to-do from our code base. Avoiding zombie code. What is zombie code? Exactly, it's commented out code for different reasons. This should be avoided. So what would this section do here? I don't know. When would this be uncommented? There are some questions we should answer. Was this accidentally commented? Do I need to refactor this too? Normally we should use source control for code history and directly delete such code which is here commented out. We should avoid this bloated header. For example, we have these examples in most of our files. The author history should be available in source control, and we shouldn't repeat ourselves with this bloated header. We should follow conventions and have the history in the source control. We should also avoid defect and change log. So for example, if you implement something, the change can be visible in TFS, in source control. We basically also like a book which isn't covered in author notes. Good. Finally, I want to tell something about the cleat comments. So we saw earlier how to-do comments can be helpful. We have these summary comments where summary comment describes the intent at the general level higher than the code level. It's useful to provide an overview of classes, but the risk with summary comments is we shouldn't use it to simply augment poor naming or code level intent. And we have the documentation comments. When it's useful basically when things can be expressed in code, so we add a link or something like that. When you're about to write a comment, think always if you could express the same thing in code. With the help of intermediate variables, eliminate magic numbers with enums, or refactor to a well-named method. And also always think, so if we commit something, we should think if instead of writing a comment, this comment can be put in source control as a commit message. Good. Next, the comments should be also the last resource. So if we cannot make the code readable so that it's expressive, then we can write a comment, but only in extreme cases. We're going to talk a bit about code formatting. So the vertical formatting is important, the vertical distance, the variable declarations and how they are declared, the same space is the same tab spaces should be used, the dependent functions should be one after the other, and we have also this Visual Studio keyboard shortcut which formats our code so that it automatically formats code which is not in line with our coding styles. Next, we're gonna talk a bit about error handling. Yeah, talking about functions. So functions shouldn't return null. Instead, we should throw exceptions if null is calculated in a function, or we should return the new empty object or a list. We also shouldn't pass null as a function argument. We should ideally handle the null case before passing the null. This way we avoid a lot of null reference exceptions we have in our code as bugs, and we should use exceptions rather than returning error codes. Good. Here is an example about why we should use exceptions. So returning error codes is violation of the command query separation and leads to deeply nested structures and is not so easy to understand. The solution would be to use exceptions. Here is an example. So we have this nested structure which checks error codes. If we would do the same thing with exceptions, we have this try catch functionality and everything is here in place, and it's much more easy, and we can concentrate on the logic here instead of this all kind of conditions. Talking about clean coding, we have to talk also about unit tests. So unit tests should have the same code quality like production code, so we should strive to keep our tests clean. We should have clean tests, one assert per test. We have this principles of unit tests. We have this first acronym, so unit tests should be fast, independent, repeatable, self-validating, and timely. And we also have these 3 laws of TDD. So first of all, we should write a failing unit test, make the test pass, and then we can refactor our code base. So we can then safely refactor the code so that the code is in best shape. So unit testing, I will stop here because unit test requires a whole course about this, but we have to talk also about unit tests because unit tests enables us to refactor our code to make it more clean, because we rely on this unit test which ensures that the code is running as expected. Talking about classes, so when should we create a new class? Basically when we have a new concept, an abstract concept or a real world concept, to create low cohesion, so methods from a class should relate to each other. Yeah, it promotes reuse, so these classes should be small and targeted, and classes should be created to reduce complexity. Once you solve a problem, it's hidden away below this class, and then we can reuse it where needed. And also to clarify parameters and identify a group of data which should be put in the same class. Classes should be strongly related. So here we have some classes which are doing too many things. So this is like the Swiss knife is like a magnet which attracts all the code. So it's not very clear what this does. Also the same like this kind of cathedral, which is so big that it is functioning also like a parking lot. Classes should have the possibility to reuse should be increased, and like this magnet which attracts too many codes, so we should create different classes for different functionalities. Broad class names leads to poor cohesion, so here's some bad naming. So my function, common, processor, manager, utility, when you see such classes, then you should run away, because they attract too many things. It's not clear what they are doing. Here we have also an example how two developers are trying to understand or naming a method, something like that. Um, and an example how to increase cohesion. We have for example here a vehicle manager with a lot of functions and methods. How can we improve this? We can create 3 different classes with high cohesion. So for example, we have this vehicle which has these 2 functionalities, and we have the maintenance, vehicle maintenance, which is doing some functionality, and we have the vehicle finance. So here we abstract away this functionality to 3 different classes, and this way the code which is related is separated, and it's much more easier to maintain. Next, we have this proximity principle. So the code which we are writing should be read from top to bottom. So the first method is a validation, and this calls to other methods. For example, here we have the validate data and another requirement. So it should be written from top to bottom. Yeah, also conditionals should be written in a clear fashion. So for example, if then, here is an example. We should compare booleans implicitly, make it simple. To have another use case is how we can refactor this to take less space and makes it easier. So the name here is suggestive. We should be also positive. So I really don't like this negative naming because it makes the code really hard to understand. Instead of having this not is not, write directly the is available. We should be also strongly typed. So if we check here for employee type with this magic string manager, what exactly is this manager? We should create an enum, and this makes it the code here easier to understand. Magic number. So for example, we have here some numbers which are not very clear. We should write clean names so the code is very clear and easier to understand. Here is an example. If age greater than 18, what does it mean? It's not very clear. Instead, we should declare a constant like legal driving age. Then it's very clear what is the intent of this function is meaning. And also, we had this example with the status. We check for 2. I don't know what this 2 means, but if you create an enum for this, it's much more clear and readable. If you have complex conditionals, one solution for this would be to create intermediate variable which expresses with the name what this conditional is doing. We can create also functions. Here is an example. So if we have here a complex checking, how can this be improved? We can, for example, create a boolean with a name which is very suggestive, and then we can check for it. Or better, to create a method which can be called from multiple places if needed. We should also favor polymorphism over switch. We have this login user with a switch. This can be refactored so that we have here a user class. We have active users. We have a base class user, and we have active user, inactive user, blocked user. So the advantage here is that if another functionality, if another type of user comes in, we don't have to modify the base functionality. We only create enough functionality in the new method, and the original code is not affected. Good. When should we refactor our code base? Yeah, most of the time, because you need to work with the code, and the code is maybe difficult to understand or to change. And one thing we can do, we saw in the test-driven development, that adding tests for regression offers us this protection, so that once we have the test, we are more confident when doing a code change, because the unit tests are like a safety net which which enables us to do the refactoring with more confident. Code reviews, we should use code reviews, and yeah, to be proactive and detect potential issues. We should have guidelines. The readability is enhanced like this, to work in pairs, to do these real-time code reviews, increases the quality code, and yeah, the naming and refactoring is easier. Once again, I want to talk about this broken window theory. So we shouldn't accept broken windows. So if we see a bad design or something which can be improved, we should act and not delay this until it's too late. And the Boy Scout rule to always keep the code clean and leave the code base cleaner after a change, as opposed to when we found it or when we began to change something. Good. Some resources which was great help for me is Code Complete, and especially this Clean Coding by Robert Martin. A lot of useful tips, and yeah, I hope you learned a lot in this presentation. So hopefully you are able to create more clean code and be a professional programmer.